Okay, we are going to do this to review what we were doing before break. We don't necessarily need to do every single one. I am going to fill them all in so they're all on Schoology so you can look back at it. I think here's what I'm going to do. I'm going to do the first column because I made ones where they're all positive, ones where there's a positive and negative, ones with a negative positive. Like I did some of each, like, yeah, I'm a genius. Yeah, I did some of each type. So I think what I'm going to do is I'll do the first column. I'll pause this. You guys can try the second column. And if we're all good, then we'll be good. If not, I'll do a couple more for you. You're looking for two numbers that multiply to equal the top number and add to equal the bottom number. And you can use Desmos, but some of them, if the numbers are small enough, you can kind of think your way through it. You raised your hand, so I'm going to look at you. Great, good. So 6 times 3 is 18, but 6 plus 3 is 9. Just real quick, let me show you how you would do that in Desmos. You would take the top number, which is 18, divide it by X, make your table, and then keep going until you get the pair that adds to 9. You see how 3 plus 6 is 9? Now, if the numbers are small enough, you can usually do it in your head, but when they get bigger, you might need Desmos. For example, this one. Let me go ahead and type that in. You would do 32 divided by X. Make your table, and we're looking for ones that add up to, what is it? 12. Now, they're both going to need to be negative because it's a negative 12, but do you see it? Yeah, 8 and 4. Good job. And they'll both need to be negative. So why is it a positive 32? The negatives cancel. Negative 4 times negative 8 gives you positive 32. But if you add these, you get negative 12. Now, when the top number is negative, one or the other is going to be negative. One of them is going to be negative, but not both. Do you want me to type this one in Desmos, or does anyone think they know it? It will be 9 and 5. 9 times 5 is 45. Now, when you add them, you want to get a positive 4. So which one gets the negative? 5. Or you could think of it like 9 minus 5 equals 4. So you can use the calculator, but at the end of the day, you do kind of have to have a little bit of number sense and know your times table. All right, this one's kind of a big number. Do you want me to put that in Desmos, or does anyone think they know it? 80. Now, even though the 80 is negative, I suggest putting a positive 80 in here because I'm not sure which number is going to get the negative. Now, you want ones that add or subtract to be 2. And we don't use decimals, so you can skip any of those ones that have a decimal. Yeah, there you go. 8 and 10. So, oh, good. Okay, so 8 and 10. Why is the 10 the negative one? Negative 2. 8 plus negative. It's the bigger one. You remembered me saying that. All right. I'm going to hit pause. What I want you guys to do is try the second column, and then we'll go over it together. All right. What did you think for the first one? 5 times. Good. Perfect. 5 times 8 is 40, but 5 plus 8 is 13. For this one, they're both going to be negative. So here, let's talk about 20 and 3 real quick. I'm really sorry that isn't there, but can we talk about it real quick? Because at first glance, it kind of, don't write this one down. It kind of seems like that would work. But to get a negative 16, you would need a negative 20 and a positive 3. And why won't that work? That will be a negative for the 60. I like talking about that, though, because that happens sometimes. And it's important to like notice that. I need them both to be negative. So is there another pair? Yeah, negative 12 and negative 5. That happens sometimes. And you know what? You know how you learn is by getting it wrong and then fixing it. And repetition. Okay. All right, 14. That would be 2 times 7. That one's not too bad. Which one gets the negative, though? The 2. Negative 2 plus 7 will give you a positive 5. Or you could think of it, if this is positive, you want the bigger one to be positive. And then 20 would be what? Yep, negative 5 and 4. Negative 5 plus 4 will give you a negative 1. Are there any from the other 2 columns that you want me to do? I will fill them out and post them on Schoology. So if you're like, hey, I want to practice the others, I'm going to put the answers up there. Okay. Go ahead and flip over. This is the new stuff.
Oh, no.
I know, you're going to learn something. So what GCF stands for is greatest common factor. Have you heard that before? Oh, you did that with fractions? Okay. We're going to do it with polynomials. All right. Greatest common factor. Shh. The most important word out of that is common. They have to have it in common. It means a number that you could divide out. So for the coefficients, and those are like the numbers, you're going to find the largest number that can divide out. What's really cool about that is Desmos will do it for you. Desmos will do numbers. It won't do variables because it doesn't know what they are. We don't know what they are either. It's a placeholder for something. But Desmos will do this. What you type in is GCF and then put the numbers that you want in parentheses. I'm going to make up an example and I'll show you. You just need to watch. Okay, so I'm going to share my screen, go to Desmos. So say I want the greatest common factor between, let me make up some numbers. Let's say between 20, 15, and 30. 20, 15, and 30. Now, before I type it in, can anyone come up with a number that would divide out of 20, 15, and 30? It would be 5. You're correct. But watch. If I do 20, 15, 30, and it tells you 5. It literally will tell you that. Now, it won't do variables, though. It will only do numbers. But because the SOL is largely multiple choice, if you can get the number part right, you can usually narrow it down. Does this make sense?
Oh,
okay. Please use your resources. Now for the variables. Now this is the part the calculator won't do. You're going to use the lowest exponent. And I know you're like, Ms. Cole, why is it the lowest? It's called greatest common factor. Again, what's the most important word out of greatest common factor? Because it's not greatest. Common. They have to have it in common. So it's going to be the lowest exponent. The analogy I always use for this is, for example, and just follow me on this, okay? If you have somebody that has $10, somebody that has $8, and somebody that has $2. 10, 8, and 2. Are you with me?
yeah.
Can you take $10 from each of them?
No.
No, because you can't take $10 from someone that only has 2. Do you get what I'm saying? It's going to be the, could you take $2 from each of them?
Yeah.
Yes. Okay, so it's going to be the lowest one. So I'll use the calculator if we need to, but I want you to try and think through this. Look at this one right here, 6 and 30. Let's do the numbers first. What number can be divided out of both 6 and 30? 6. All right, let's leave a little space here. We're going to write 6 off to the side. Now that's actually it. You can't take an X because this one doesn't have one. You can't take it if it's not there. With me? Okay, so 6 is it. That's all we're going to divide out. So put your parentheses. You are anti-distributing. You are undistributing. Does this make sense?
Yeah.
Instead of multiplying through, you're dividing out the 6. So you're going to divide every term by 6 and just see what's left. And that's what'll go in those parentheses. So what is left for this first term? It's just X, right? Plus, and then 30 divided by 6 is 5. And that's your answer. Look, if you were to take the 6 and distribute it back through there, you would get what you started with. We just did it in reverse.
Wait, what?
Right, but I hadn't taught it yet. Okay, let's try another one. Numbers first. What can you divide out of 10 and 30? Bigger than 2, bigger than 5. 10. Okay, so we're now leave a little space. We're going to put 10. Can you take out an X or an X squared or anything else? No, why not? This doesn't have it. So 10 is it. Put your parentheses. You're going to divide both of these by 10. You're anti-distributing. Yeah, exactly. If it's not there, you can't take it. Okay, so what's left from the first term? X squared, good, minus 3. And then that's your answer. If you took the 10 and distributed it back through, you would get what you started with.